Very good afternoon. Today, I would like to present synthesis and characterization of silver nanoparticles immobilized onto rice husk, silicon dioxide aminopropylsilane in reduction of nitroarene. For introduction, we have a background of the study. Alright, so rice husk is one of the agricultural waste which has high content of silicon and consists of sodium silicate, carbide, and nitride. Then we immobilizing the silver into rice husk, meaning that we not mobilize the silver. So we move the silver into the rice husk and make it static, and we produce the silver nanoparticles. And it used because of the surface reactivity, making it the best to use in catalytic activity. Reduction of nitroaromatic compound using silver nanoparticles give fast reactions in converting into amine group. Now we go to the problem statement, and this research is focusing on the immobilization transition metal, which is silver, and we extract the silica from the rice husk hash as has been also been studied. Okay, and then we characterize and the catalytic activity of the silver nanoparticles is able to conduct. And however, most of the research does not provide sufficient information about the catalytic activity of the silver nanoparticles. The catalytic activity of the nanoparticles after the reduction process will be looked into it in the preliminary result. The objective of our study is first to extract silica from RHA or rice husk ash using alkaline extraction method. Then to investigate the silver nanoparticle produced by immobilized silver with aminopropylsilane as a cellulating agent. And third, to characterize by using selected instruments. And last, to analyze the product from the reduction of nitrobenzene. As we can see here, there are several literature reviews. I've been separated into different points of view, which is rice husk silver nanoparticles, rice husk silica, and also silver nanoparticles. So first, we see that some research has emphasized on the rice husk itself. So rice husk contain about 20% of rice weight, where it consists of 15% of cellulose, 30% of lignin, 15% to 20% of silica, and 10% to 15% of moisture. It has high content of silica in the part of rice grain. And the average composition of well-burned rice husk is consists of 90% of amorphous silica. So we can see here it is 90% of amorphous silica, only 5% carbon and 2% of potassium dioxide. So meaning that it is high in the silica content. So the synthesis of silica will produce rice husk and silating agents such as APTMS. Aminopropyl trimethoxysilane is used to modify the silica. Right, and this is some research in 2016. Immobilization of silver nanoparticle allowed the nanoparticle to have high stability and catalytic activity. Okay, all right. Stabilizers such as sodium borohydride was used to facilitate in this research. By using instant nucleic generation with Ag plus ions, which is unstable, changes into Ag nanoparticle, producing a more stable silver nanoparticle. And Ansari 2018 has stated that more stable silver nanoparticles give higher resistance and it increases the catalytic activity. Next, we move into the literature review. Still in the literature review, however, the second point, which is the nitroaromatic compound. Nitroaromatic compound is one of the dangerous environmental pollutants which are released to the environment are toxic, and it was toxic to its human and aquatic life. So the toxicity of this compound was due to the presence of nitro group in the structure of the compound. All right. Meanwhile, because of the toxicity to the human and aquatic life, so we want to need to reduce it into into several compounds. So we can see that the reduction of this compound using silver nanoparticle is cheaper, it has shorter and fast reaction compared to the other transition metal. Silver nanoparticle provide a better site of attachment for nitroarene and reducing agent such as potassium borohydrate towards the substrate molecule. So we're going to move into the flow chart of our methods here. Rice husk was washed and remove the dirt, stir with 1 molar acid nitrate, and it was burned at 800 degrees Celsius for several hours. And then rice husk ash was stirred in sodium hydroxide was 1 molar. APTMS as the silylating agent was added and titrated with hydrogen nitric acid, and then it was 6 times using distilled water, and it's dispersed in 0.003 mole of sodium borohydrate and add some solution drop by drop, which is argentum nitrate until yellow solution appeared, and we add nitrobenzene, sodium borohydride, 0.3 gram of argentum in the solver of ethanol, and reaction was stirred for 4 hours, and the catalyst is filtered and dry. And lastly, the product identification by using the GCMS. So the catalyst characterization was used by several instruments such as Fourier transform infrared spectroscopy, scanning electron microscopy, Brunner Erna Taylor instrument, and XRD X-ray diffraction method. So this is the result and discussion. This is the characterization of the RHA, silica RHA, C, and also AG RHA C. This is the first peak, second peak, and the third peak. So we can see that there are several functional groups appear here for RHA. The most important peak is 1054, which is identified as the silanol or ISI, and then this is some fingerprint here 7698, and this is the most important peak here. It was shifted towards 1034 after we added the sodium the argentum or silver, and it appears several the peaks here was disappeared after immobilization with silver. So for the surface morphology, the topography image of RHA at magnification of 500, we can see that here it shows that rice husk has a long and irregular shape with numerous micropore structure. And this shows that the rice husk have been fully broken out during the thermal decomposition, and the rice husk is burned in a buffer furnace 800 by making it to have a numerous pore. And this is the 2000 magnification. Silica RHC after treated with nitric acid, and is clumped in together, which form into a cluster of silica, and the micropore structure of the silica is small. Alright, this is the topography image after we immobilize the AG. AG RHNB is smaller in size than the silica. Where the nanobit is scattered around, there are no large pores seen in the figure, and it also can be seen that the surface of RG is not very smooth. This is the table of result from BET, Bernal, Emmett, Taylor, where we can see that the total surface area of with RHA is 120, but after we immobilize or producing the RHA silica is increasing the total surface area. However, after we include or we static by the silver or we immobilize the silver into the silica, it reduces towards the lower surface area. However, we can see that total pore volume is also decreasing. Meanwhile, the average pore size is increasing, meaning that the average pore size for particles is increasing, and the size for average of pore size is increasing compared to the RHA itself. However, the total surface area after immobilization with the argentum or the silver is in reducing the total surface area because of the pore size is included in the silver is increasing the size, okay, increasing the attachment of the RHA itself, so it will lower the surface area. This is the raw SRD that we do not normalize. Then after we normalize, we can see that the 2 theta here is at 21.9. Then it shows that diffraction peak is porous. Okay, the broad peak of the rice husk is the porous structure. And it is also show that the RHAC silica is 23.8 and is also amorphous and porous structure. And we can see that this is the diffraction peak of silver RHE when it was narrowed at 24.16. So according to Kumar and Ghosh, the diffraction peak of silver is at 17, 32, and 46, meaning that this is another type of silica. So we only have one, which is 24.16, meaning that it is a broad peak and it is the porous structure and it is amorphous. Alright, this is the last method, which is the product identification. So we can see that this is the GCMS chromatography peak here. There are four important peak here, which is the first one is solvent, and this is internal standard. And we can see that there are three peak, which is 5, and at the retention time 5, 14, and 15. So from the product identification, we can see that the first product is azobenzene and azoxybenzene. So as the conclusion, silica from the agriculture waste, which is from rice husk hash, has been successfully extracted. Argentum silicate nanoparticle was successfully immobilized with the silica from rice husk hash, which is synthesized with 3-aminopropyl trimethoxysilane as a silylating agent, and the conversion of nitrobenzene has been analyzed when using GCMS, where nitrobenzene has been converted into azobenzene and hexoxybenzene, where this product is widely used as a dye in the industry as compared to the most toxic product or reactant. I think that's all from me, and thank you.